We're going to start looking at adding and subtracting rational expressions today. And so the last few days we were working on multiplying and dividing. And multiplying and dividing fractions, you were allowed to, when you multiply, you were allowed to just multiply the tops, multiply the bottoms, reduce, or you could look for your diagonal canceling, right? All that good stuff. Oh, look at all that canceling. So multiplying fractions is a lot different than adding fractions, and it'll be the same with rational expressions. When you're adding fractions, you cannot cancel diagonally. That 2 and 4 cannot be canceled. When you are adding your fractions, you need a common denominator, right? So you need to multiply by 4, multiply by 4, bring your plus sign. Multiply by 3, multiply by 3, then you need to keep that denominator, add the numerator, and now that you've simplified your fraction, if you can reduce it, at this point you can reduce it. The other option is if I give you something like 2 over 4 right at the beginning, you can reduce a fraction within, right? You can reduce the fraction, you just can't diagonally reduce, okay? When you're in this adding stage, you can't reduce here. You must combine those to 11 and then reduce. Those are the common mistakes I see when we get into the algebra with rational expressions, all right? So you need a common denominator and you cannot cancel diagonally, okay? So let's try a few. So in this case, I have my common denominator and I'm adding, so you just keep your denominator 3w and you add the numerators, right? If it's adding, you write adding. If it's subtracting, you write subtracting. You combine like terms and there you go, okay? Non-permissible values, again, are the values in the denominator, right? That would get you to 0. So w can't be 0. So this addition simplifies down to this expression except when w is 0. Okay, so again, I have my common denominator, so I keep my common denominator, and this time I'm subtracting 41m squared minus 2n squared. M squared is 39m squared. And now at this point, if I can reduce, I can. Oh yes, 3 goes into both. And so there you go. And then my non-permissible values, or the restrictions on my variable, would be that t cannot be 0, right? Because you cannot have 0 in the denominator. And 3t squared, when does all of that equal 0? Well, divide by 3, you get t squared equals 0. Square root, oh, when t is 0, right? Cannot be 0. If your denominator is a binomial, again, if it's the same, you just keep it, right? And then you add the numerator. 7 plus 2 is 9, okay? Such that x cannot be equal to 5. Sometimes your denominators look like they're common, but not quite. X minus 2 and 2 minus x are not the same. But a reminder, when you factor out a negative, right, you factor out a negative, you can reverse the order, right? The negative x becomes positive, the 2 becomes negative. What I like to do then is I like to take that negative and I like to move it to the numerator. Okay, now I have a common denominator. So now I'm going to have my common denominator of x minus 2, and in the numerator I have 7x plus negative 14, right? Or that negative just could have switched the sign and been subtraction instead of adding. Your choice how you want to do it, okay? And so yes, I don't like that adding negative, so I would probably just rewrite that as minus, okay? Oh, can I reduce? Possibly. I see a GCF in the numerator. So I'm going to factor out that GCF and get x minus 2. Right? Sometimes you factor and you're like, yeah, that didn't help me, so you just scrap that and go back to your original. But if it helps you, you keep going. So you factor out the, and oh yes, it does. So all of this is equal to 7, except x can't equal 2, because 2 minus 2 is 0, and same thing there, 2 minus 2 is 0. So x can't be 2. All right, so this time I have denominators that are completely different. It's kind of like 5 and 7, right? There's no common factors within those two numbers. So if I had 5 and 7, my common denominator would be 35. I would need 5 times 7. Same thing here. If I have y and x, my common denominator would be, I would need both. Whatever they are, it needs to be x times y, okay? So now I need to create a common denominator. So I have to figure out what do I need to multiply to get there. I multiplied by x, so I need to do the same to the top. So 5x times x is 5x squared. I write my plus sign. I like to write it all in the numerator like this rather than separate fractions, because when we get to subtraction, everyone forgets to subtract everything. So this is the way I do that so people don't make that mistake. And then I'm going to get to adding y, or sorry, multiplying by y to get xy. So I'm just creating equivalent fractions with a common denominator. So now I'm going to get 3y squared. I look to see if I can factor. I can't factor, so this is my final answer such that x can't be 0 and y can't be 0. Right? I should be saying can't be 0. All right. So now we're going to get into more difficult ones, and we're going to practice finding common denominators, because that's when people struggle the most. What is the common denominator? So in my first question, you'll notice that I do not have any plus or minus signs. So there's no plus or minus signs. I just go through each factor separately. I go through the numerical parts. So I look at the 6 and the 8. The 6 and the 8 can both become 24. So that's my LCM. Okay? And then I go through the x squared. I have 2x's and 3x's. Well, if I multiply 2x's by 1x, I get 3x's. So I take the highest one, right? 3x's. Because x squared can become x cubed through multiplication. And I have 3y's and 1y. So this is kind of the opposite of GCF. It's not what I'm taking out, it's what they can both become, right? The LCM is going to be the largest power this time, not the smallest power. So now I know that y can become y cubed by multiplying by y squared. So this would be my common denominator, which I would continue on. A lot of people with B try to tell me it's x plus 1 because, hey, look, I can just add 1 to that. But when you're finding a common denominator, it's not about adding or subtracting. You have to multiply. You have to multiply the two numbers, right? Because if I had 5 and 4, the common denominator can't be 5. I can't just add 1 to the top and bottom. That's not a proper proportion. It's only through multiplication or division you create a proper proportion. So I have to be able to multiply. So here's my little rule I like to remember. When I have a binomial or trinomial, I'll put brackets around it. And just like before with canceling, it's all or nothing. I need that whole factor, right? You can't just take part of it. So I need both of those. I need x and I need x plus 1. That is my common denominator. I need them both. Right? Sometimes when your binomials are matching, it's already common. So if it's already common, I only need it once. Right? So that's common to each. Same thing with my x's. My x's are common, so I just need a single x. My y is not common, so I need a y in each, right? So to get my common denominator, this one doesn't change at all, but this one would have to be multiplied by y, right? And that's all. So if I have x plus 2 and x plus 4, and there's no common factor between them, and they are not common, right? X plus 2 is not the same as x plus 4. They just both start with the same number, but when you start adding, they both change. So if they're different, I need them both. Okay, and this is where it's going to start to get big and messy in some of the questions, is because you have to, what am I missing here? Oh, I'm missing my x plus 2. What am I missing here? Oh, I'm missing my x plus 4. So there'll be a lot of foiling and multiplying, etc. when you get to the numerators. Okay, let's look at E. So first, you'll notice that 5 and 3 are monomials. They are not part of a binomial or a trinomial. So when I have monomials, I just do GCFs LCMs like I normally do. 5 and 3 can both become 15, right? That's their LCM. And again, x minus 3 and 3 minus x look the same, but not quite. So I'm going to factor out a negative, and I'm going to move my negative to the numerator. So and so that's going to become x minus 3. The negative I factored out has gone to the numerator. It's not part of my denominator anymore, so now I have an x minus 3 and x minus 3, and there you go. That's my common denominator. So what am I missing here? Oh, I'm just missing a 3. What am I missing here? Oh, I'm just missing multiplying by 5. We could get a common denominator and continue from there. Okay. So again, 3 and 9, common is 9, right? X plus 1 and x minus 1, it's tempting. They look like something can happen, but they are different, so you need them both, right? The only time they are really the same is if you can factor something out and they become the same. That only happens when you have reverse subtraction. The only other time is if I had like negative x minus 3 and an x plus 3, right? I could factor out a negative 1 and get negative x plus 3. That would be the only other time. Okay, so you need both. So here, this would be a harder question. I would need the 3, and I would need an x minus 1. Here, oh, I just need an x plus 1 to complete the denominators. All right, so now that we have practiced finding common denominators, let's actually complete the entire question. So we have 3 over 5x minus 5y over 2x squared plus 2, which I can say is over 1. So now I need a common denominator, so I write my denominator. Between 5, 2, and 1, it's 10. Between x and x squared, it's x squared. Okay, now I go through each separate ratio and I complete the ratio creating this common denominator. So 5x times 2x gives me 10x squared. So whatever I do to the bottom, I do to the top, and I write that answer right here. Then I write my subtraction sign. Here, 5x squared multiplied by 5 gives me 10x squared. So whatever I do to the bottom, I do to the top. So I get 25y. And here I need everything. So I'm going to multiply by 10x squared, and I multiply by 10x squared. And I write my plus sign, and I get 20x squared. Okay? Now I look for GCFs in the numerator. I look for factoring. I don't see anything possible. There's no GCF, there's no factoring, and this trinomial is not our usual x squared x nothing, right? It's kind of all messed up, so that's where I stop. Okay. And again, you could do your non-permissible values. Right now, I'm going to continue on assuming my denominators are not 0. I'm just going to focus on the adding and subtracting. Where would you always look for non-permissible? You'd always look at your original denominators. All right, common denominator here, 3 and 4, it's going to be 12. B and no B, well, I need a B. A and no A, well, I need an A. I'm going to write them in alphabetical order, 12AB. So here I'm missing 4 and a B. So I'm going to get 16AB plus. Here I'm missing a 3 and a B. I always double check before I move on because you hate to make that mistake and do all that work with the wrong number, right? Take more care in the beginning because one mistake in the beginning messes you up. So now, since there's a binomial up there, that 3a has to go to both, okay? 3a has to go to both. Since there's a plus sign here, when I multiply it out, I'm not going to worry about brackets. I'm just going to multiply it out. If that was a minus sign, I would have to keep the brackets because then I have to apply the subtraction to everything. So I'm going to get 6ab minus 27b squared. Okay? And then I can see that I can collect like terms. I can see that 16ab and 6ab can combine into 22ab minus 27b squared all over 12ab. Okay, so let's just double check. So that's 16ab. Oops, no, I figured something was wrong. I have made a mistake. Let's back up. I said to be careful, and what did I do? I made a mistake in this one, because this should be 12ab, and this should be 12ab. So there, I just did what I told you not to do. So we're going to get 16a squared, and we're going to continue on with our plus sign, ignoring the brackets because that's plus. So now I'm going to get 6ab minus 27b squared. Okay, I could check to see if this could factor, but when I factor this, you're going to be getting two binomials. And since this isn't a binomial, why bother? There's not going to be any canceling. The only thing that could cancel would be a GCF, right? And I do not see a GCF, so then I know I'm done. My common denominator is going to be x minus 3 and 2, I need them both. Always write the monomial first. It's a good habit to get into. So there's my common denominator. Here I'm just missing the 2, so I'm going to multiply by the 2. So I get 10 minus. Here I'm missing the x minus 3, so I need the x minus 3. So I have the minus 3 on top, right? So I'm going to write the 3, and I'm not going to multiply it out. This is where mistakes are made. So when you have subtraction, don't multiply it out yet, because you all end up with 3x minus 9. But it's not 3x minus 9, because you need to multiply that negative 3 to both, right? Be careful with subtraction. Take this extra step. It's so worth it on a test or quiz. So I'm going to get 10 minus 3x plus 9 all over, and denominators, do not multiply them out, because you do not have to collect like terms with other numerators, and in the end, you want them factored to look for reducing and simplify. So always leave those denominators factored, but the numerators you must multiply out, because you are going to be combining the two numerators together. So now I'm going to get 19 minus 3x all over 2x minus 3. Okay, no GCF, so I can't reduce, and there's my final answer. And if I did a non-permissible value, x can't be 3, right? X can't be 3. Oops, I think I moved my screen here for recording. Let me just fix this up here for one quick second. What did I do? There we go. All right, so now what we're going to do is we're going to, let's see if we have another example. I think we have 2 more examples left. All right, in this case, we have a binomial and a binomial that are not the same, so we need them both. This is where it's going to get a little more complicated. We need them both. So I need an x minus 1 on the bottom, so I also need an x minus 1 on the top. Here I need an x minus 5 on the bottom, and here I need an x minus 5 on the top. Look, here it's positive, so again, we can be a little relaxed about having to write it out. We could actually expand it in without making too many mistakes. So here I'm going to expand my 3 into the x minus 1, and I'm going to get 3x minus 3. I'm going to now write my plus sign, right? This plus sign matches up with this plus sign. Okay. Now I'm going to multiply the 7 in. Since it's positive 7, I can ignore these brackets, and I'm going to get 7x minus 35. Okay. Keep the denominator factored. Do not expand. Now collect like terms in the numerator. Keep that denominator factored. And then, oh, I see a GCF. I see the GCF is going to be 2. But when I factor out a 2, I get 5x minus 19, which is not helpful at all. The 2 doesn't cancel, and the 5x minus 19 doesn't work. So even though I see I could factor, it doesn't get me anywhere, so I'll remain with this answer right here. Okay, this one looks the best. Okay, I always check to see if I can cancel, but if you can't, don't bother. And again, such that x can't be 5 or 1. All right, let's go down to our last question today. So, in this question, since I have a GCF here, I first find my, since I have a common monomial here, my LCM is what 2 and 2 can both become. Well, they're the same. They can both become 2. I have an x minus 1, which I need, and I have an x minus 3, which I will need as well. So here I'm just missing my x minus 3 on the top and bottom. And here I'm missing my x minus 1 on the top and bottom. Okay, this time I have a subtraction, so I'm going to be super careful. I'm going to take an extra step here. I'm just going to write out x minus 5 multiplied by x minus 3. And again, a reminder, this subtraction sign here matches up with this one here. And then I'm going to have x plus 1 multiplied by x minus 1. So I took this extra step so I don't make mistakes. I'm going to FOIL this out, and then subtract. Keep the bottom factored. So we can do some of this in our head or scrap paper, but just write the answer to this FOILed out here so we don't have tons of steps. So use scrap paper for foiling and all that stuff. So I'm going to get x squared minus 3 minus 5 is minus 8x plus 15. Keep it in brackets. Subtract. Now I'm going to get x squared minus x plus x minus 1. Right? Keep the brackets. That minus sign will mess you up if you go too fast. And then keep the bottom factored. Now I need to distribute that negative in. So I need it to become adding a negative and a positive. Now I collect like terms. So x squared minus x squared is gone. I have a negative 8x, 15, and positive 1 is 16. And on the bottom, I now have negative 8, or sorry, I have my 2, x minus 1, x minus 3. Possibly, I might be able to cancel something. Let's take a look. So I'm probably going to rewrite this as 16 minus 8x. 16 minus 8x. Let's keep it nice and neat that way. So now I'm going to have 8. Let's check it out. Does it help me? So now I get 2 minus x all over 2, x minus 1, x minus 3. Well, that binomial didn't help, but the monomial helps. I can cancel and reduce here. So I can reduce and reduce, right? And so my final answer, let's move this over to the right. My final answer is going to be 4, 2 minus x, all over x minus 1, x minus 3. And my non-permissible values, going back to the very original, x can't be 1 or x can't be 3, right? And so that is my simplified version. So a reminder, never expand the denominator, keep it factored. The numerator must be expanded so that like terms can be combined. After combining your numerators, check to see if the numerator can be factored in an effort to further simplify. So once you've combined, you then check to see if it can be further simplified, but not until you've combined them. Too many people get like, oh, 2x plus 4 all over 3x, or 6x, and go, oh, look, I can cancel there, but they have not. You cannot do that until like terms have been combined, okay? So be careful.